Hello, my name is Mohammed Ahmed and today I will be teaching domestic electric circuits. So let's begin that particular important topic, and that's an amazing topic. I hope you all are going to enjoy this topic here. Okay. So if I talk about domestic electric circuits, then it is an arrangement that how our electrical appliances at our homes are connected to different wires in our home. So what we have observed in our homes that we used to receive electric supply. We used to receive electric supply from a pole or underground cables in some cases. So first of all, what will happen is that particular cable from the pole that will be coming to our home, and once that cable enters into our home, then that particular cable which has entered in our home having black insulation, it has further two wires. One wire is that red wire of red insulation and another wire is there of black insulation. Another wire is of black insulation. So this is how these wires enter into our home. So here in the diagram we can also observe the same. One of the wire that is of red insulation, that is called as a live wire, and another wire that have the black insulation, that is called as a neutral wire over here. So first of all, these two wires pass through the fuse. About fuse we will be discussing in detail later on in this particular topic. So that particular live wire passes through that particular fuse. Only the live wire passes through the fuse. Live wire passes through the fuse, and that particular fuse is the main fuse of our house, right? Then what happens is, now both these wires, the live wire and the neutral wire, now they pass through this electricity meter. So what do we understand by this particular meter? So this is the electric meter which measures electric energy. It is a device which measures amount of electrical energy used in a month. That device is called as electricity meter here. So it measures electrical energy in the unit of kWh that we have already studied in our electricity session. So after that, the wire, live wire and the neutral wire, they pass through a distribution box which contain main switch and fuses for each circuits individually. So you may have seen such distribution box of wooden cover in your house. Let's elaborate this particular domestic circuit practically in detail as we see in our home as well. So let's have a look regarding the same. So you can see this particular diagram here. So in this diagram you can see different appliances are connected. Like I can see that there is a TV connected, and I can see that there is a table on which any other appliances are also installed. Like I can say a bread toaster must be there, or it can be the computer also, and many different appliances. There are lights in our houses, so they are also connected. So here in the diagram we can observe that this is our meter. So from meter we have already seen that two wires are coming out. We will also be talking about the earthing wire. The two wires are coming. One is the live wire and another one is the neutral wire. So here the process of earthing starts as well, right? We will be discussing about the same as well. So basically the earthing, it is a wire which is deep inside the earth, or there is a metal plate inside the earth. Suppose this is our earth. So we have buried a metal plate inside that, and we have connected one wire. Color coding we are taking for that particular wire as green. So this green wire, which is called earthing wire, that is connected to the metallic body of appliances. Metallic body of the appliances, right? Because if there is any leakage of electric current, to any metallic body of the appliances, then that particular leakage of electric current can pass, or that particular leakage of electric current Yes. Any leak, any leakage of a particular electric current can cause, it can cause electric shock, because if I am touching that particular metallic body, then what will happen? I may get electric shock. So what will happen? That particular leakage, when it is passing to the metallic body, so that metallic body, if it is connected to the earthing, then it is at the potential of earth. It is at the potential of earth, because that wire is, that particular metal body is connected to the earthing. So it is a safety measure to connect the earth wire. So here we can all observe that how the live wire and the neutral wires are connected to the different circuits, right? So this is the meter, and then we have a fuse box or circuit breaker here. Then we have wall socket here, as we have seen that in the previous diagram also. So if I talk about the socket connection, then we have these types of holes in our socket. So the upper one, which have large cross-sectional area, that is for the earthing. This one is for the earthing, and one is for the live, and another one is for the neutral wire here. So this is how they are connected to the different color coding wires over here, right? And the type of connection which we are doing at our home is the parallel connection. So let's elaborate about that too. So this is our parallel connection. As you can see, this is a simple diagram to show the parallel connection in our house. So about series and parallel combination, we have already studied in our previous chapter as well. So let me give you an example how this parallel connection is providing lot of advantages to us. Let's have a look on the scene. Here you can see how the electric current is passing through the parallel combination. So this is a diagram representing the parallel combination of the two bulbs over here. This is how we can see that. So here we can see that separate currents are there for both the bulbs, right? So one of the important advantages is that for any condition, if one bulb get damaged, then other bulb will not stop working in this case. So that will also be working. Another advantage is that, right, both the bulbs will be working at a constant voltage over here. So that is the main advantages of the parallel combination over here. So we can summarize that. What are the advantages in simple terms? For example, if one bulb gets fused, then other bulbs will also not stop working here. This is one of the most important advantage of it. And other advantage is that all the appliances connected in parallel are working at a constant voltage. All the appliances connected are working at a constant voltage over here, because in parallel combination the voltage is same. So this is about the advantages of the parallel connection. Now let's talk about that particular electric fuse about which I was telling you in the beginning as well. So this type of fuse we may have seen at our house. Let's understand about it. So in this fuse we can see there are contacts. We can see these particular contacts will fit into this, and we have a wire here which is connected like this, as we also can see that particular in the diagram also. So this particular electric fuse, it works on Joule's law of heating. Joule's law of heating. So what will happen is this particular wire, which is called fuse wire should have low melting point. Low melting point should be there with the wire, right? What will happen is once the electric current will pass through this wire, or we can say once the high electric current more than the rating of the fuse wire will pass through this particular wire, then this wire will melt. Then this fuse wire will melt. So this is how it will interrupt the circuit, right? So this is how this particular electric fuse works here.